A hyperbola is a set of points, the difference of whose distances from two fixed points is the same, and the fixed points are called foci. This is like an ellipse. The difference is it's the difference of distances and not the sum. So here we have a hyperbola centered at the origin. And there are foci, they're within the bendy part, just like with the ellipse. So these are actually outside of the shape, on the other side of the shape from the center, if you will. And the idea is for any point on the hyperbola xy, there's a distance from one focus to that point, call it d1. There's a distance from that point to the other focus, call it d2. And we would say that the absolute value, d1 minus d2, is equal to a constant. The development is almost identical to that of the equation for an ellipse, so I'm not going to develop the equation for you, but what I will do is write them down. First, we need the idea of what's called a transverse axis. The line that goes through the center and the two foci is called the transverse axis. Now we can have a horizontal transverse axis or a vertical transverse axis. An a hyperbola that has a horizontal transverse axis would have an equation that looks like x squared over a squared minus y squared over b squared is equal to 1. In the case of a vertical transverse axis, we would see y squared over b squared minus x squared over a squared is equal to 1. These equations can also show that something's been translated by introducing h and k. So x minus h, the quantity squared, minus y minus k, the quantity squared, x minus h, the quantity squared, over a squared, minus y minus k, the quantity squared, over b squared is equal to 1. Likewise, for the vertical transverse axis, notice again that k is associated with y, h is associated with x. The way a and b fit into the graph of a hyperbola is a little bit different than what we saw with the ellipse. And the way I write these down is a little bit different than I see in textbooks. Namely, textbook authors tend to want to put a squared underneath the positive term. So you might see y squared over a squared minus x squared over b squared is equal to 1. Whether they're a or b makes no difference to me, but I do have a reason for doing it the way I do it. Let's turn to our picture, which has a horizontal transverse axis, and the distance from the center to a vertex is a. So the square root of the number underneath the x squared term. B, which could be bigger or smaller than a, smaller than a, shows up in an orientation that's perpendicular to the transverse axis. And A and B together define a rectangle. That rectangle is called the fundamental rectangle. It has dimensions 2a by 2b. And the deal with this rectangle is that drawing lines that go through the corners of the rectangle from the center of the hyperbola give us what we call asymptotes. And the hyperbola has a vertex that touches the fundamental rectangle and then bends up and away, but then becomes asymptotic with those diagonal lines. So these lines here are called asymptotes. And if you think about the slope of the asymptote in terms of rise over run, rise will be associated with B, run will be associated with A. So our asymptotes here are going to have equation y minus k is equal to plus or minus b over a times the quantity of x minus h. Plus or minus because one asymptote will always have a positive slope and the other will always have a negative slope. H and k, being the center of the hyperbola, are two coordinates of a point where the asymptotes will intersect. And h and k could, of course, be 0 in the case of the first equation that we wrote down. Now, a hyperbola that has a vertical transverse axis, instead of opening left and right, will have branches that open up and down. There's still going to be a fundamental rectangle, and there will still be asymptotes. And the way I've labeled my equations here, B will still be the vertical distance between the center and the vertex in this case. A will still be the horizontal distance. And so the way I've written this, my slope will always be plus or minus B over A. With other textbook authors, you'll often see this A squared underneath the Y squared, the B squared underneath the X squared, and then they have to give you two sets of equations for the asymptotes, and I get to avoid that here. As for the foci, we wrote them down here. The distance between the focus and the center is going to be C. And for a hyperbola, we have what looks just like the Pythagorean theorem, C squared is equal to A squared plus B squared. Now, again, A could be bigger than B, B could be bigger than A. It makes no difference as far as the hyperbola is concerned. What makes it so that a hyperbola opens left or right, or up or down, or up and down, is which term, x squared or y squared, is positive.